So, hello friends. Today's topic is uh, worker node components. Okay, so worker node components. Okay, we will see. Okay, so first I will tell you that I have just created a cluster. Okay, in the previous session we have already seen that how to install the kubectl and how to install the eksctl. That is the client required for running the Kubernetes commands. Okay. So I have already started the EKS this cluster. Okay. So I am so this is my jump host server. Okay. This test server is my jump host server from which I am running the commands. Okay, onto the EKS cluster which will be running on AP South one. Okay. So my EKS cluster is getting created in this region. Okay, so currently it is getting created. Okay, because it took around 10 to 15 minutes. That's why I deliberately started before this session. Okay, so that we can save that much of the time. Okay, so our jump host server, that is jump host server, is in US East one. Okay, and our EKS cluster is in AP South one. Okay, so if we go into this AP South one region, okay, so this is my AP South one region. Okay, so we'll go to the EKS, Elastic Container, Elastic Kubernetes Service, and there we can see our cluster is getting created. Okay, so the cluster name is Pratik. We can see by this name. Okay, so it is getting created and just refresh whether it okay. So it has been active now. Okay, although it is still running, it is still running some commands on the CloudFormation stack. But here we can see our cluster is getting created. Okay, so if you see this cluster, you will see a lot of tabs over there in this cluster. Okay, so one tab is resources. So if you see in the resources, right? So these are the workloads. Okay, these are the workloads. What we have seen in the resource type, that workload is that's pods, replica sets, and deployment sets. Okay, so these are the very important, let's say, entities in the Kubernetes. These entities carry the traffic. Okay, so you can relate these terms with the traffic of the Kubernetes. Okay, so these are, you can describe it is like a smallest means pods is the smallest entity of the traffic. Okay, so depending on the scalability, these terms are referred over here. Okay, pods, replica set, and deployment set. So we will be seeing in detail these three workloads. Okay, so there are also other workloads, that is testful set, daemon sets. We will see in the upcoming sessions. Okay, so we can see there multiple tabs over there. Okay, so this cluster is getting created in this AP South one. Okay, this region. Okay, so currently this node group is still not yet created, right? Because we can see these are the some commands which are getting executed on the cloud formation stack. These are still need to be fully executed, right? That is why the reason why we do not see any node groups here. Okay, so let the complete starting of the cluster. Okay, so uh, there are another tabs like networking, right? So networking, this provides the networking for the our EKS cluster, okay, which is being created. So this is the VPC in which our EKS cluster is getting created, okay. This is the IP range, and these are the subnets which are getting created for the our EKS cluster, okay. So any of the so EKS cluster is managed by our service provider. Okay, so that is we are not managing. So these are the subnets, and these are the VPC which are getting created background in the background by the service provider by that is meant by AWS. Okay, so EKS is a AWS managed service. Okay, in that we just manage the worker nodes, and the control node takes care of the uh, by the AWS provider. Okay, so these are the VPC, these are the subnets, and these are the security groups created by the AWS service provider itself. Okay, that we don't need to take any take care for this. Okay, so uh, let's check whether our installation is complete or it is still running. Okay, so these are some resources and compute and networking for this cluster, Pratik. Okay, so uh, we are yet to see that node group is still not created. Okay, so we just refresh it and check version. You can see this Kubernetes version. Okay, so it is not allowing me to show. Okay, so see that now you can see this node group. Okay, node group is status is still creating, right? So node group implements the basic compute scaling through the EC auto scaling groups. Okay, so let's wait for the some. Okay, so whenever you okay, it is still our cluster is still creating. Okay, let just wait for to it finish. Okay. Okay, so it is okay. So it has finished the installation of the EKS cluster. Okay, so you can check by the command kubectl get nodes. Okay, we have already seen this. Okay, so you can see that our two nodes are ready. Okay, so we can get the details about these nodes by the kubectl get commands because I have given here the uh, two because by default it has created the two nodes. Okay, so whenever your cluster is created, okay, so whenever you create the cluster, one directory will be created. Okay, and that is dot cube. Okay, so just go to this. Let's open LRTH. Okay, d. Okay, so that is the hidden directory. Okay, ls hyphen lirth. Okay, that is dot cube. Okay, so you can see that is dot cube is created. Go to this directory. Okay, and there you can see the configuration file. Okay, this is config file. Okay, so if you see this file, no, vi config file. So whatever the configuration of these EKS cluster is, okay, so these configuration exist in this file. That is the config file. So you can see the API version. Okay, so lot of there are a lot of many information like region, the cluster name, okay, so the user and certificate, okay, so these are the details means these are the uh, certificate will be automatically downloaded here, okay, so this is the certificates and this is the server, this is the context user, okay, so this configuration is readily available in this file. Okay, so This file will be created automatically when you run your EKS cluster. Okay, so there is also users. Okay, cannot see because we need to update it. Right. Okay, so okay, I have added the new context. Okay, so we already seen that this is the jump host EC2 server. Okay, this is a platform to access your worker nodes. Okay, from here we will be accessing the worker nodes that are installed, that are created in this AP South one. That is here our resources are getting created. Okay, this is the cluster, right? So our control node is managed by the AWS. Okay, and these are the this is our worker node. Okay, so these are the our worker nodes. Okay, kubectl get, these are the our worker nodes. Okay, so we can see that these are the two EC2 instances that is being created on the AP South one. Let's see, we can here we can see that in the EC2 instance. Okay, so the IP is 192.168.16.127. Okay, 16.127. Okay, so this is AP South one. Okay, so it is taking some time. Okay, okay, just wait it to finish. Okay, uh, till then it is loading. We'll see the Kubernetes workload, that is the pod. Okay, so MS Paint. Okay, so see, these are the worker nodes. Okay, if you see, these are the work nodes, and you can verify with the IPs what we have seen here. Okay, sorry, what we have seen here, 16.127 and 55.12. Okay, so we can verify here the IPs whether, okay, it is taking some time. Okay, so see, this is the 55.12, right? This is the 55.12, and other will be that 66.127. So we can verify like this. Okay, so let's see the our Kubernetes workload, that is pod. Okay, okay. So pod. Okay, so I will just copy it from here because it is, this is my GitHub in which my Kubernetes libraries are there. Okay, so I will take here from the pod.ml. So Kubernetes is are the YAML files. Okay, we have already discussed about this. These are the set of the YAML instructions. Okay, that are being executed in the Kubernetes environment. So okay, so just this pod. Okay, pod. Okay, so we can. copy raw file and okay. So this is our pod. Okay, I will tell you. Just change the color here. Okay, so pod. Okay, so if you see this the pod, this is the sample YAML file of the for getting created the pod. Okay, so in this we can see that there is a first entity is API version. Okay, so API version one is this is common. Okay, so what tells us this is since we already know that the control node of this Kubernetes is managed by the AWS. Okay, so we have already seen that the first request whenever you executed the command from the client tool, right? kubectl apply. So first it will go to the API server, right? So this API server will be coming request to this API version. Okay, so we are creating this file so that your request getting communicated with the API server. So that API version is here 1, V1. Okay, so it can be some V1 apps also in the replica sets whenever we will start with the replica set, there we will be able to see this. So this is about the API version. Then the next is the uh, kind is pod. Okay, so this is the kind. Okay, so kind means it it designates that this is the file is of the pod. In terms of replica set, it will be here replica set. In terms of deployment, it will be here deployment. Okay, so kind defines the identifies it is a corresponding workload. Okay, so what so the next is the metadata. Okay, so what metadata is? Okay, so metadata is just the name of the your pod. Okay, so you will have some name for the your pod. Okay, so it that section comes under the metadata, and one is the name and another section is the labels. Okay, so labels is also very important. Okay, I will tell this whenever we will discuss the replica set. Okay, and then our uh, most important field is the specifications. Okay, so specifications is what the container. Okay, so we have already seen that uh, we have already seen that first we will the there will be an image, right? First there will be an image. Okay, on top of that image we will be having on top of that we will be having okay, sorry, on top of image we will be having the container, right? Container, and on top of the container there is a abstraction layer, right? What is that? There we call be sorry, there we will be calling it as a pod, right? So this is this is our pod. Okay, so these specifications, what we can see here in specification that it is the container. Okay, and in container there will be one image. Okay, so from image what we will be having your application code bundled in the form of package, right? That is called image. Okay, so when you will run this image, okay, so that your container will be created, okay, and when your container will be created, your pod will also be created, right? So these are the definitions, these are the specification we are defining in the pod.ml file, okay. So these things come under the specification, okay. So here we are having the nginx image, okay, so the container will be created in the form of nginx image, okay. So application will be created of the nginx image, okay, in the form of container, and then the then the uh, pod one, okay. So if you check any pod is getting created, or okay, my system is getting so just refresh it. Get kubectl, sorry, kubectl apply hyphen m pod.yaml, right? Execute. So you can see that our pod is created, right, here. So how can you interrogate whether pod has been created? Kubectl get pods. Okay, so it is pending. Okay, it should be running. Okay, I think Docker is not there. That is the reason why it is pending. Docker, Docker nodes. Okay, let's try to run this, whether Docker is installed or not. Okay, it pods. Okay, still it is pending. Okay, okay, okay. To give access Docker daemon to run this server. Okay, okay, we will remove this file. Okay, kubectl, kubectl delete hyphen af pod.ml. Okay, so we are deleting and we'll try it again. uh, kubectl apply hyphen f pod.ml. Okay, kubectl get. Okay, still it is pending. Okay. Mm-hmm. Okay. I'll check why this is pending. Okay. But just let's complete this topic. Okay. So this is about the pods. Okay. Uh, okay. Hmm, just a minute. Why it is in pending? kubectl describe pod my app. Okay. So describe if you want to see the more details of the pod. Okay, you can use this command kubectl describe pod and pod name. Okay, so here we can see that label is app, status is pending, is none, container, image. Okay, host port. So it has the warning is failed scheduling. 2 minute 2 second default schedule. Two nodes are available. Too many pods. Change found for the incoming pod. Okay, maybe this is the billing issue. Zero, too many pods are available. kubectl get nodes. Okay, kubectl describe nodes. Check one of the nodes here.
Okay. On demand. Mm-hmm. Starting complete. Invalid disk capacity. System. Okay. There seems to be some resources issue over here. Mm, okay, so that might be the reason. T2 micro and T2 small. That might be the reason. Yes. Okay. We will change the instance type from T2 macro to T2 small. Maybe I think that is the issue. I'm also not sure, but let's try. Actions. Okay, it is still not stop. Just wait for a few seconds to let it stop. Okay, so it is stopped. Just try to change the instance settings. Change instance type to T2 small. I think this is the reason. See, memory is greater into 0 in T2 small, right? I think it will work now. Okay, now same it's doing for the another one. So the CPU is still the same, but the memory is somewhat doubles. Okay, I'll try to up them now. Start the instance. Okay, so they are running now. Now check whether we are able to run it or not. See, now you are getting the pod is running, right? So what was the issue? Why it was getting into pending state? Because there were no enough resources to get this pod schedule on that particular node, on those nodes. Okay, because see, we have selected the whenever I created, so when I created the cluster, no, that time I have selected the T2 small, sorry, T2 micro for the worker nodes to get it installed. But since T2 micro is having lesser memory capacity than the T2 small, so I should have given there the T2 small. So that was the reason that resources were small. Okay, so that is why our pod was not getting running over there. Okay, so now it has been running. So this is about the pod. Okay, so our next topic is what? The replica set. Okay, so replica set. Let's get into the replica set. So as the name suggests, the replica. Okay, sorry, here not. So as the name suggests, replica set. Okay, so replica means the number of copies. Okay, so number of copies means uh, if we single pod, okay, single pod, single application, that won't be enough, right? So in order to have the redundancy, we should have the multiple copies of the pods, right? So we will see now the replica set. Okay, so okay, so this is our, okay, this is our replica set. Okay, so this is get pods. So already this pod is running. Okay, I think we have deleted that file, no? Okay, no worries. Just check the nodes are up or not. kubectl get nodes. Not ready. Okay, so these are the ready nodes. Because we have restarted the instances
these worker nodes. So new IP is getting created. Okay. So no worries. We'll try to run the replica set. So just create one file vi replica set dot yaml. Okay. Okay. So we have already seen this file, right? See the indentation of the fields over here. This is very important in order to have the correct YAML file. Apply hyphen f replica set.yaml. It is very slow. Okay, so replica set is get created. Try to check the number of pods whether it is getting created or not. Get pods. Okay, so they are still pending. That is the same reason, right? Okay, so we have already seen that how to get it running. Okay, by mistakenly I have selected that uh, by mistakenly I have selected that okay T2 micro instead of T2 small. That is the reason. Okay, kubectl. I will try to delete those nodes. Okay, those which are not in use. Okay, so kubectl delete nodes. I think I am not able to delete these. Okay, so deleted. Try deleting the other also, the not ready one. Okay, now execute the kubectl get nodes. So those two are which are in not ready state are has been deleted. Now check the pod status kubectl get pods. Okay, still it is in pending state. Okay, I think the reason is the same that too small. Okay, I think we have already changed that one. No. Okay, just checking the instance type of those worker nodes, whether it is T2 small or T2 micro. It is taking very time. Okay, so my since my cluster is having the T2 micro given, okay, so that is the reason why it is creating the cluster T2 micro only, okay, and it is automatically getting switch off the T2 small one. Okay, so this is happening automatically. Okay, since I have given the since I have given the cluster as a in while creating the cluster, I have given the node name, given the okay, it has gone now. The instance type, the worker node type as a micro. That is the reason why it is getting pending. No worries. I know the reason why it is pending. So it was my mistake to give to I had not given the T2 micro over there instead of T2 small while selecting the
Okay, so I'll tell you this command. No, this is the command we have already seen in the last session. Okay, so over here, okay, this T2 small. I have deliberately make it T2 micro. Okay, so no problem. So now we will see the deployment. Okay, so deployment is almost the same. Okay, so deployment we are having the okay, so deployment. Okay, sorry. So this is the deployment file over here. Okay, so deployment is nothing but like replica set only. Okay, but see, now we are having API version as apps colon v1, same like for replica set. Kind will be deployment. Okay, since this is a deployment YAML file. Metadata is name of the deployment file, that is nginx deployment. Okay, and the specification is replicas and selector. This is same like the uh, replica set only. Okay, this is nothing but the replica set only if you look carefully. So what is the difference then from the deployment and the replica set? Okay, so replica set is a self-healing. Okay, so when one of the pod you are getting deleted. Okay, so if I deleted one of the pod, okay, kubectl, let's say delete pod, let's say delete this 8R6. Okay, so it will automatically create the new one. Okay, so you have deleted pod, now it will create the new one. See, the new one is created in the form of 8G9, sorry, 67G, right? So this is the self-healing capacity of the real replica set. Okay, the scalability in order, like we have seen the auto scaling concept in the EC2 instances. Okay, the same concept is in here in the Kubernetes is implemented in the form of replica set. Okay, so then what is the difference between then our deployment and the Kubernetes and deployment and the replica set? Okay, so in the deployment, okay, we can enable the rolling updates and the rollbacks. Okay, that is that is one important thing over here which distinguish between the deployment and the replica set. You cannot implement the rolling updates in the replica set. You can enable only in the deployment. Okay, so rolling updates, let me see. Here we can see in deployment update. Okay, see, here it is deployment. Okay, so this is the rolling. Okay, so if you see this file, no, this rolling updates. Okay, so here you can give the rolling update like here. So maximum unavailable is 25%, max search is 25%. So if you are having any four pods running, okay, and any new feature you have implemented, okay, so you have to test that in the production. So what you will do, out of four, you will select only one and test that one pod whether that new feature is getting tested right or not. Okay, so this is the same concept over here in the rolling update that at a time you will only maximum surge is 25%. So out of 20 out of four pods, only one pod will be updated with the new one, and that will be deleted. Okay, so maximum unavailable will be 125%, that is one pod out of four, and maximum surge will be 25% out of one. Okay, so one at a time, one pod will be deleted and created with the new feature. Okay, so in order to test your uh, updated application, let's say with some feature you are adding in your application. So one by one you are testing that pod, your application. So first you will test with the one,
Then if that is satisfactory, you will make it here 50%. Then two pods will be created with the new feature application. Same like 75 and same like 100. Okay, so this concept of the rolling update is not there in the replica set. So that is the reason. So that is the difference between the deployment and the replica set. Okay, so if you see this here also, this labels is matching with the replica set. Okay, so this is nothing but your, so this is nothing but your total replica set only. Okay, so this is about the worker node concepts. I hope you understand this, and in the coming session we will be coming with more concepts of the Kubernetes. Okay, so thank you for joining and thank you for your patience. Bye bye. See you.